may have seen, a lot of you, a few weeks ago, the amazing pictures of Jupiter taken from the James Webb telescope. And our next speaker is going to be talking to us about that. And you may have seen the pictures when the telescope was sent up and it was unfolding all its mirrors, you know, absolutely amazing pictures. So we're going to hear from Stephen Wilkins. And Stephen is a reader in physics and currently serves as the head of astronomy. And before Sussex, he was at Oxford and Cambridge universities. And his research focuses on studying the first stars and galaxies to form in the universe. He's going to talk to us now. And Stephen, I noticed that in your biog, your interest in astrophysics was all sparked by a computer game from the 90s. So I'm dying to know what that was now. What was it?
That was a game called Frontier Elite.
Ah, Frontier
so
Elite.
Some people may remember it.
There we are. Please welcome Stephen.
Thank you very much, Claudia. It's great to see so many people here today. I hope you're having a really good weekend back here. I've been in awe for the last month or so because we've been waiting nearly 30 years for this new space telescope, and we finally had it launched. This is it. And hopefully you can see the connection with the previous talk here, so we can see the honeycomb pattern, because, you know, although mine and Beth's work is completely, literally worlds apart, everything's connected. So what I'm going to talk about today is some of the very first results from this amazing new facility that we've got. This is the James Webb Space Telescope. And hopefully over the last few months or over the last year, you've heard some of the information about this, because it really is, you know, our most impressive scientific instrument ever created. Now, some of my particle physicist colleagues might disagree with that. They've got their Large Hadron Collider, but really, this is it. This is a telescope which is $10 billion. This is not just, although you wouldn't believe this by looking at the media, a NASA program. In fact, this telescope, the James Webb Space Telescope, actually, like its predecessor, the Hubble Space Telescope, is a huge collaboration between NASA, the European Space Agency, so us, and also the Canadian Space Agency. It also includes thousands of astronomers and scientists and engineers across the world. There are tens of thousands of people who are going to use this facility over the next 10 or 20 or even 30 years. This really is what's going to shape our understanding of the universe over this period of time. Okay, but just to point out, there's actually really, really strong UK contribution over here. And this is actually the least impressive image I'm going to show you. This is a camera. And one of the cameras, actually, this is 4 cameras. One of these cameras over here was built here in the UK. So actually, the most advanced camera, of course we would say that, on this telescope was built here in the UK. Mostly built up in Edinburgh, but then lots of the testing down in Leicester. And then we've been using it recently to learn about the universe. Okay. The other great thing that the European Space Agency did, so our contribution, or your contribution, so this is your tax money that's gone into this, is that we actually launched the telescope into space. So here we have an Ariane 5 rocket. This is Europe's largest launcher. You can see, hopefully, the nice big ESA logo there. And if you squint really, really carefully at the top of the rocket there, you can actually see the James Webb Space Telescope logo as well. Okay, so this rocket here is actually launching James Webb. And this was a really, really special launch, because this is a launch that had been delayed for maybe 10 years, right, after a development of around 20 years. And this telescope finally launched, but it launched on a very special day, because it launched on Christmas Day. Oops. It launched on Christmas Day in 2021. I was actually supposed to go to this launch when it was due to launch about 5 years ago. But unfortunately, because of these delays, that no longer happened. And the way that I celebrated this launch was actually peeling carrots in my parents-in-law house in Leeds. So I had a little iPad there, and I was watching this momentous launch while peeling carrots. And it was just such a weird thing at the same time. So after many, many years of delays, we finally got this telescope. And since then, we've been testing the telescope. It has to fly a long way, so this telescope actually sits in space 5 times further away than the moon. Okay, so this is 1.5 million kilometers away. Okay, and from that vantage point, it's able to take these amazing images of our universe. And I'm going to show you just a handful of these images now. Okay, first of all, I'm going to start off as close as we really can, and hopefully everybody can recognize this. This is Jupiter. This is Jupiter as viewed by the James Webb Space Telescope. This doesn't really look particularly impressive, considering that we've had probes around Jupiter being able to take much more impressive images in the visible light that we can see with our own eyes. But this is a completely new view of Jupiter, because what James Webb is doing, which is different from Hubble, is actually viewing our universe in the infrared. And that's light that we can't see with our own eyes. So what you see in this image, in fact, there's a huge amount of interesting things in this image. What you're seeing is the storms in Jupiter, and the hotter the storm is, the brighter it appears. So you can see, for example, the very bright circle down the bottom right, that's actually the Great Red Spot. So this is one giant storm. That's a very different storm than the surrounding areas. Other things you might be able to see is that there's a big black spot. For those of you who are science fiction fans, this has got nothing to do with 2010, A Space Odyssey. This is actually the shadow of one of Jupiter's moons. And if you look really carefully on either side of the disk of Jupiter, you can see a faint ring. That's actually a ring. So it isn't just Saturn that has a ring system, Jupiter has one as well. And if you look carefully, you can see a few little smudges around. They're individual moons. So Jupiter is about the closest thing that the James Webb Space Telescope can look at it. So what I'm going to do now is look further out into our universe and see what else we can see. Well, this is probably the most boring image that I'm going to show you, but it's tremendously important. One of the things that the James Webb Space Telescope was meant to do was to not look at planets in our own solar system, planets that have been studied very well for a long time. It's to look at planets around other stars. Right? You could call these alien planets. That's exactly what they are. They're planets which don't belong to our star. And what James Webb can do is not just look at those planets, not just find them, it can tell you what's in their atmospheres. So in this planet over here, what these little wiggles, these dots are showing you is that in the atmosphere of this planet, there's actually water. Now, water is tremendously important, right? Really, really critical for the existence of life. And one of the things that we hope to be able to do in this area of science with the James Webb Space Telescope is actually detect things like water, but also carbon dioxide, ozone, and oxygen in the atmospheres of other planets. And so down the line, James Webb will have the capability of actually saying whether a planet has life on it. I can't guarantee that it's going to discover life out there in the universe because we don't know, but we finally have the capabilities to actually do that test. So I'm really hoping in the next 5 or 10 years, that is one of the most amazing things that we see. That's kind of a civilization-changing discovery if we're not alone in the universe. Now, I'm not talking about little green men here, I'm talking about little green plants. What we're going to see here is, if we do detect life, it's things like vegetation, or the signs of vegetation. Okay. Other things that James Webb can do is study where stars and planets came from in the first place. This is by far my favorite image that James Webb has taken. This is a real image. This is a real part of our own galaxy. Okay? And what you're actually seeing here is a region of the galaxy which has lots of gas and dust. And from this gas and dust, you form new generations of stars and planets. Okay, so you can look at this image online, go and download it from the ESA website or the NASA website, and you can zoom in. You can get much better detail than I'm showing you here. But many of the little points of light that you're seeing here, these are new stars that have just been born that might have new planetary systems around them. Stars don't just live, they die, right? So some stars live a few million years, stars like the sun will live a few billion years, and other stars will live, as long as the universe will live. But stars like the sun often end up like this. This is the remnant of a star which has died. Now that may seem really kind of depressing and sad, but this is actually crucial to our existence here on Earth. Because when stars die, they release elements that they've created during their lifetimes into the wider universe. So things like oxygen, nitrogen, iron, all of these elements which are vital for us and all life, were created in events like this a long time ago. So when the universe first started, it was only really hydrogen and helium that was created. Everything else was created in events like this and giant supernova explosions. Okay. So stars dying is, sad in a way, but it's really vital. We wouldn't be here if progressive generations of stars hadn't lived and died before us. Okay. We can go further. We can look at entire collections of stars and gas and dust. These are a collection of very famous galaxies. Each one of these blobs here contains hundreds of billions of stars, and they're merging together in this system over here. So what we're seeing here is, billions of stars. But what I work on is using telescopes like Webb and like Hubble before it to actually explore the very earliest part of the universe's history. And the way we can do this is by just looking out into the universe. So when we look at the moon, we don't see the moon as it appears right now. We see it as it appeared about a second and a half ago. If we look at Jupiter, we see it as it actually appeared about 45 minutes ago, sorry. And if we look at this star-forming region, the Carina Nebulae, we're actually seeing it as it was 8,000 years ago. And this collection of galaxies, we're seeing it as it appeared 280 million years ago. Now, if we look further and further away, we look further back into the universe's history. And in fact, what myself and my group do here at Sussex is we take images like this. This is one of our deepest views of the universe. And we look at every single one of those little blobs of light, and we work out how far away it is. And from this image and images like it, so things like the Hubble Ultra Deep Field, which came before it, we can explore back across almost the entire history of our universe, all the way back to the Big Bang and the very first stars and galaxies to form. And just to zoom in here, in one of my new favorite galaxies that we discovered, we have this slug galaxy over here, this galaxy that we're actually able to see even further back because its light has been magnified and distorted by this nearby galaxy. And that's the end. With Webb, we've only really just scratched the surface. We've had a month worth of data, and already it's started to revolutionize our view of the universe. Over the next 10, 20 years, we hope to learn so much more about our universe, but really crucially, create all these beautiful pictures that anybody can enjoy. Thank you very much.